Avoid time travel and fail safe for stage tables. And look, I will focus on this specific aspect because I've seen so many people, so many customers creating default tables without being aware that this will incur additional storage and eventually some performance penalty. You don't need for intermediate tables time travel and fail safe. Let's see first what time travel is and how it can be implemented in Snowflake. So, this would be a very, very short crash course on the time travel support in Snowflake. I'm in test public here, the test public schema, and I will create or recreate a TT table. Yeah, very simple table with a name, and I will populate it right away with John Doe entry. So look, if I execute not just this one but the next one, so I already executed use test public. Yeah, it's very trivial. Look, this is what I have inside, and from now on, I will try to use this shortcut. Yeah, select everything from could be replaced by table. You have a table statement in Snowflake. Yeah, that's the way you can use it. And look, I will just save a checkpoint here. The last query ID. So this is a query ID of this previous statement, table TT. Okay, you'll see why. Because yeah, definitely right now I can look at the content of this table before executing this last statement. So I can do this eventually passing the session variable like this. Okay. So this is one possible way to look back in time. Okay. Time travel, this is what it does. It saves additional data to be able to look back in time to some data that exists there before some other eventual changes. Okay, we didn't change data for now, but still, when you append at the end at or before, you can look back at some point in time, and this point could be referenced, as you can see here, by a statement, by a query ID, basically, or as a negative offset, yeah, or as an absolute timestamp, yeah. Let's have a look at this one, yeah, offset minus 1000 seconds. Okay, remember that when you look back in time, that's a relative number, and this should be always negative because you look back in time. Let's see what we got here. Okay, that's interesting. Time travel data is not available for table TT. The requested time is either beyond the allowed time travel period or before the object creation time. So, when you look back in time, you should pass here a valid number that goes back in time uh, within the period between the creation of the table and the current moment. Okay, this is important. So when I pass here minus 1000 seconds, the table was not created. We had no table at that time, and you get an error. Okay, let's see something else. Okay, day tower. Okay, that's an absolute time, and I will go back in time from the current time with 2 hours. Yeah, so as you may expect, yeah, I'll get a similar error because the table was not created there before. Timestamp, current timestamp, interval, yeah. That's just one variation, yeah, with this one. And look, I can pass this one also. Go back in time 10 days before. Okay, so this is not good, but what I can do to get something valid, okay, look, I can do this because, yeah, definitely I created this table more than 1 minute ago. So this is offset in seconds. If I say this, okay, I will get something valid. Okay, that's good. Before doing anything in here, I will say update TT set name John Mayer or yeah Jim Mayer. Okay, where name is John Doe. So I will basically replace this one. Okay. And now, if I go back in time, look, I can call this one. Now, let me copy this and I will do it twice. Okay, let's see what's the current value. As expected, this would be Jim Meyer right now. But if you look back in time 60 seconds ago, you see this was John Doe. And basically, you can recover this one. You can create, let's say, a new table. Yeah, we'll do this. We'll do this next. But you can create a new table with data from the past and then replace basically the current table with the data from the past. So you can do mistakes, let's say, like this one, and you can recover your data by looking back in time. Look, time travel in Snowflake is controlled basically by this parameter, and this parameter can be set, at the account level, at the database level, schema, or table level. Okay, whenever you create a new table, you get this by default, and by default, this value is one, regardless of the addition. Yeah, we'll review all this, but for now, yeah, if you do this show tables like TT, okay, basically you look at the TT table and have a look at this one. Okay, retention time. You see this one by default is this was one, and it is still one. If you look at the parameters, data retention time in days parameter used for the table TT by default. Okay, this was one. Default is one. By default is one. Number of days to return the old version of delete updated data. Okay, so keep this in mind. Yeah, I repeat this again and again. Time travel in Snowflake is a data recovery mechanism. Okay, this is not used and shouldn't be used for analytics. Yeah, we can use it eventually. We can play with this. You see, I issue here SQL query statements. Yeah, basically, but this is just to go back in time to eventually recover data. What if we want to change this one? Look, I will do alter table, set this one to 3. So this worked here. Is this always working? No, not really. Because if you are in the standard edition, you can change this to maximum 1 day. Here I am in my trial account. I selected the enterprise edition. With the enterprise edition for permanent tables, keep in mind this works for permanent tables, you can extend this time travel period, retention time, to 90 days, but not over 90 days. Okay, 90 days is the maximum. So that's why usually you cannot use this one for analytics because you don't have enough. You cannot keep enough data to go over the year and so on. And look, I already presented to you here a possible recovery mechanism. Yeah, I presented you a change, a table change. You can go back in time to recover, but you can actually drop the whole table. Look at this one. We'll drop the table and we'll query the table. Yeah, the table no longer exists. It does not exist, not authorized. Okay, but you can do one drop. Okay, that's a new statement, and it is fully related to time travel. Undrop. And you can undrop a database, a schema, in this case a table, and look, yeah, I recovered the table. Okay. You can do this as well, yeah, definitely. As I said before, look, timestamp, yeah, interval 2 hours, but let's say interval 120 seconds. I want to recover. Okay, I want to create basically a new table. Okay, that's a C task what I have here. I want to create a new TT2 table from table TT with the data that I had there 2 minutes ago. And let's see if this works first. Okay. Okay, this worked. And I had Jim Meyer there. I can drop the table TT right now, and I can rename the new table TT2 to TT. And let's see. Is there? Yeah, yeah, is there. Why did I do this? Because right now, look, I can say again, show tables, okay, but with history. Like TT, and I will show, yeah, both TT and TT2 in this case. But if you do this, look, I have what here? I have TT, okay. Let's see what I have. I have the TT, which has been, you see this one here. TT was dropped also. If you had history, this will show also your dropped and recovered tables. Okay, dropped on, and if dropped on is not null, yeah, you see here. I dropped before our TT table with a retention times 3, but I recovered it because this is active. This is still on. Yeah, you can see this one. Yeah, you can look at the data here created on. Yeah, this was, I recreated this one basically by altering the name TT2 to TT. That's why I don't have a TT2 here, because TT2 has been renamed to this one, to TT, the top row here. Okay, guys, so I hope you have a better understanding, if you didn't have already, about how time travel works in Snowflake. Okay, back to our point here, back to our stage tables or intermediate tables, because this was a problem here. That's a course about Snowflake pitfalls, yeah, potential Snowflake misunderstandings. And I've seen this in real life again and again. People, yeah, have a tendency, of course, to create tables by default, but they don't realize that by default, you will get tables with time travel and fail safe. Let's review these concepts and, in the context of these intermediate tables, I remind you that usually in an ELT extract load transform data pipeline, you upload stage files from a stage, definitely, into an intermediate table, which is called stage table. From this table, further, you have to apply some transformations into the permanent target table. And yes, this target table will be queried, yeah, by your data analyst and so on. And it may require time travel because it contains important data, and you may need a backup. Yeah, time travel and fail safe are just other forms of backup. A quick review: time travel. uh, you can extend, you can get extra days of storage. Okay, in the enterprise edition for the permanent tables is up to 90 days. Yeah, one by default. Yeah, 0 to 1 by default in the standard edition. Okay, uh, by default, as you can see here, 0 1 extra day of storage in standard, yeah, for permanent tables or for any transient or temporary table. Okay, keep this in mind because this applies to all sorts of tables, including the temporary or transient tables. And this is controlled by the data retention time in days parameter, which can be set at the account level, database schema, or type. Set it to 0, yeah, to disable, yeah, in the account level, because this is inherited. If anyone creates a new database schema or table, and you already have a data retention time in the account level, this would be inherited down. Okay, but keep in mind, because you cannot you cannot prevent anyone to create, let's say, a table with a different data retention time in days. They can still create explicitly, create table, okay, something, and set the data retention time in days to a value greater than 0. So you cannot basically disable this in a Snowflake account. You have also another parameter, minimum data retention times in day, that you can use to enforce longer time travel. So, what's going on? Let's say you're in the enterprise edition, and you want for any new table, okay, any new permanent table, to have the minimum data retention time in days, regardless of what some user may specify at the create table time, uh, at starting at, let's say, 5. You may want to force anyone to create any table with a minimum of 5 days of extra day storage, yeah, to be able to recover this. So you can use min data retention time in days. Okay, fail safe. Fail safe is something different. Okay, you get beyond the time travel, you get an additional 7 extra days of storage for permanent tables, remember only. Okay, you can see that transient and temporary tables, they have no fail safe. So you can get the point already when you see this, that if you want no time travel and no fail safe, you'll have to create your tables as transient or temporary. By default, automatically you'll have no fail safe, but you still have to specify something there. Data retention times in days 0, even for transient or temporary, because by default they will get 1 day, and they can get in any addition 1 day of time travel. Okay, so if you want no time travel as well, you'll have to find a way to set the data retention time in days, either inherited, at some parent account database schema level, or explicitly in the table, in the transient temporary table, to set it to 0. These are the time travel use cases, yeah. So this is all you need, guys, if you want to understand how time travel works and how to use it from SQL in Snowflake. So looking back in time, and this is happening in tables, yeah, in the select statement, yeah, select, and you say from, and then at or before, and here you have the different options. You can look back in time by an offset or by an absolute timestamp. You can pass a stream name. Okay, that's a specific use case. I'll not go into detail. Check the documentation. Or you can use a statement, a query ID, with at or before. Okay, at, yes, we look back in time, including that specific point. Before is except that specific point. Let's say you have a statement, and that statement was an update statement, yeah, and this changed the table. Of course, there is a difference if you use at or before. Before, we look at the data that you had before using the update statement. At, it will look at the data changed as well by that statement. Yes, you can use at or before with create clone, okay, in zero copy cloning. Yeah, we'll see next with a database schema or table. And we've seen that the way you can restore dropped objects is using, let's say, undrop. Yeah, that's one way to do it. If you drop, let's say, the database schema or the table, drop, type name, undrop. Okay, restore the drop object, one of these database schema and table. And we've seen that, yeah, you can use show types with history to show also the dropped and the recovered objects. This is very important, yeah. That's an example that shows you how you can incur additional cost, yeah, with time travel and fail-safe, with when you don't need it. You don't need it, yeah. Let's say in this case, yeah, you have a 1 terabyte, yeah, that's a large table, permanent table, okay, with 30 days, yeah, time travel, yeah, in the enterprise edition, because otherwise in the standard you get maximum 1 day. And let's say, yeah, you made a mistake. Yeah, you made a mistake. You want to drop it after one single day because you realize, the on-demand storage cost would be $23 yeah, per month for this 1 terabyte permanent table. Okay, so you just realize, yeah, look at the active bytes here. If you dropped it after one single day, that's good. $23 divided by 30, yeah, because you kept it up for only 1 day. So this is where you had live data now deleted that you were able to query, but for just 1 day. And so you paid anyway 77 cents, okay, less than $1. It's almost nothing. This is good. But look, guys, just because you set 30 days time travel for this one, the bytes in time travel, okay, for 1 month basically, would cost you $23 because this is data still kept hidden for the retention period that you define, 30 days in this case, in case you want to recover the table by an undrop. So Snowflake will keep this one for the retention period you define here, there for 30 days.
It's in the back. You don't see it. If you look at the tables are not. The table is no longer there. Okay, that's some backup data you keep there, and you'll pay for it. Okay. Not just this, but even after the time travel period, after 30 days, you'll still get 7 days. Look here for the fail safe. 23 divided by 30 days multiplied by 7, okay? Because you'll keep this for 7 days. You still pay more than $5, yeah, past the time travel, but still kept for 7 days internally in case you want to recover the table. And in this case, fail-safe can be recovered only by calling the customer support. And what they say is this could take hours or days, yeah, to recover some data. So this will not happen in many cases right away, yeah, because they don't keep this data available on an SDD, let's say, SSD, let's say, on a fast disk or something. They may keep it on a tape or anyway something cheap. So remember this one. These are some key points. ETL stage tables, yeah, ELT stage tables do not require time travel or fail-safe. Yeah? These are intermediate tables, and don't spend money on storage. Yeah, with this one. Avoid fail-safe by using transient temporary tables. Yeah, because they get no fail-safe. Yeah, automatic. Permanent tables they get 7 days. 7 days fail-safe. Avoid time travel with data retention times in days zero, set to zero. So you still have to do this. And yeah, regardless, you can use a permanent table, but if you set data retention times in days to zero, okay, you can avoid this. And yeah, you can set it as the account level database schema or a table. Yeah, it will get inherited. You cannot permanently disable time travel in an account. This is very important. People may be confused here, and what can I say? This is a potential pitfall, yeah, and definitely from Snowflake, but for us, for the customers, because for them this is good, yeah. That's the way they implemented this. But if you don't want absolutely time travel, yeah, in your account, you cannot disable it unless, yeah, definitely you'll be the only one as a DB administrator to create tables. But otherwise, anyone creating a table could set a different data retention time in days there. Okay. New permanent table defaults are 1 day time travel plus 7 day fail safe. Yeah, remember this. We reviewed this. New transient or temporary table defaults are 1 day time travel plus no fail safe. Okay, but they are still 1 day. Use time travel only for data recovery. Yeah, not for analytics. It's not made for analytics. Okay, you may be tempted to say, "Oh, it's part of SQL. You can see it in SQL queries. Let's build some monthly reports with this one." Well, you can try to do it. I did it in the past, yeah, but just for fun. It's not meant for this kind of analytics. It's meant just for data recovery.